Hello everyone, welcome to my YouTube channel. In this video, I will explain voltage shunt feedback amplifier analysis. This is a basic block diagram representation of a voltage shunt feedback amplifier. Okay, here voltage sampling is used at output side and shunt mixing is used at input side. Okay, so I will explain this voltage shunt feedback amplifier with the help of simple diagram. Okay, any feedback amplifier has two blocks. One is amplifier. One is amplifier represented by letter A. And another block is feedback network represented by beta. So for amplifier, here load resistance is connected. So this is a voltage shunt topology. So at voltage sampling is used at output side. That means here same amount of output voltage is applied to the input of the feedback network. So voltage is constant at parallel connections. Voltage is constant in parallel connections. So here parallel connection is used. So parallel connection is required. Shunt connection is required. Okay. సో ఇక్కడ ఉండే వోల్టేజ్ నే ఇన్పుట్ ఆఫ్ ఫీడ్బ్యాక్ నెట్వర్క్ పంపించాలి. సో వోల్టేజ్ ఎక్కడ కాన్స్టెంట్ గా ఉంటుంది చేంజ్ అవ్వకుండా అంటే ప్యారలల్ కనెక్షన్స్ లో కాబట్టి హియర్ షంట్ కనెక్షన్ ఇస్ రిక్వైర్డ్. ఓకే, అండ్ షంట్ మిక్సింగ్ at input side. So shunt mixing at input side. So this is shunt mixing. At which parameter is affected in shunt mixing? At input side, shunt mixing is used. In shunt mixing, which parameter is affected? Obviously, current is affected. Shunt లో voltage affect అవుతుంది, current affect అవుతుంది కాబట్టి ఇక్కడ ISS. So the source parameter and the output of feedback parameter must be the same. So this is IF. Okay, ఇక్కడ ఏదైతే పారామీటర్ ఉందో I ఉంటే ఇక్కడ కూడా IA ఉంది. ఇక్కడ వోల్టేజ్ ఉన్నప్పుడు ఇక్కడ కూడా వోల్టేజ్. సో ఇక్కడ IS ఉంది కాబట్టి ఇక్కడ IF. So obviously the input is II. So IS minus IF is equal to IA. Because of negative feedback, IS and IF are out of phase with each other. Okay, so cancellation takes place. So we'll get II is equal to IS minus IF. So what is the output of amplifier? V0. Why? Because here voltage sampling is taken. So same V0 is applied to the input of feedback network. Now coming to the formulas, amplifier gain A is equal to V0 divided by IA. So amplifier gain with feedback. So the overall output is V0, overall input is IS. So V0 divided by IS. Beta is equal to feedback network. So IF is the output of feedback network. IF. V0 is the input of feedback network. So IF by V0. These are the important formulas. Now coming to the equivalent circuit. So first we have to draw the output portion of the circuit. Okay, here output portion of the circuit is represented in terms of gain. Output parameter is represented in terms of gain. Gain A is equal to, in voltage shunt amplifier, gain A is equal to V0 divided by IA, amplifier gain. So A into IA is equal to V0. Okay, from this formula. So according to Thevenin's theorem, a series resistance, equivalent resistance R0 is connected here. So of course here RL is there, load resistance RL. So this is the output portion of the circuit. Now coming to the input portion, just here Ri is there, input resistance of the amplifier. So here shunt mixing is used. Which parameter is affected? Current. So here IS is connected. IS is connected. Okay. Now feedback network beta. So voltage sampling. So we need shunt connection. So shunt connection. Shunt mixing. Here also parallel connection, shunt mixing. Okay, this is the equivalent circuit of a voltage shunt feedback amplifier. Now analysis. Amplifier gain with feedback AF is equal to V naught divided by IS in voltage shunt feedback amplifier. We know that II is equal to IS minus IF. Just observe the first this diagram. Just observe this diagram. Here IS is there. This is IF. So IS minus IF is equal to II. So we know that IS minus IF is equal to II. So IS is equal to II plus IF. So II plus, instead of this IF is represented in terms of feedback factor. We know that beta is equal to divided by IF divided by V naught. So IF is equal to beta into V naught. Beta into V naught. So IS is equal to II plus beta into V naught. So II, we know that amplifier gain is equal to A is equal to V naught by IA. From this formula, here IA is equal to V naught by A is substituted. Beta into V naught. That is equal to I naught. So V naught is taken down, we'll get 1 by A plus beta. Sorry, this is IS. This is IS. So IS is equal to 1 by A plus beta into V naught. So IS is equal to 1 by A plus beta. So A is LCM, 1 plus A beta to V naught. So IS is equal to V naught into 1 plus A beta divided by A divided by A. So by simple cross multiplication, V naught divided by IS is equal to A divided by 1 plus A beta. So this V naught by IS is equal to amplifier gain with feedback. So AF is equal to A divided by 1 plus A. Just observe here, output is V naught, input is IS. So this is also called trans resistance amplifier. Now coming to the input resistance of a voltage shunt feedback amplifier. Input resistance. So RIF is equal to voltage, input voltage by input current. Here the input voltage with feedback is Vs and current is same. Sorry, here shunt mixing. So input voltage is same Vi and current is changed because of shunt mixing. So Vi divided by Is. So Ri is equal to Vi divided by Ia. Ri is the amplifier input resistance without feedback. So we know that Is is minus If is equal to Ia. So Is is equal to Ia plus If. Simply instead of If here, beta into I naught. Sorry, beta is equal to If divided by V naught. So beta into V naught is substituted. Okay. So II plus beta is V naught. So amplifier gain A is equal to V naught divided by Ia. So V naught instead of V naught here A into Ia is substituted. So Ia is taken common, we'll get 1 plus A beta. That is equal to Is. But I want RIF. RIF is equal to Vi divided by Is. So both LHS and RHS is divided with Vi. So Is by Vi, that is equal to 1 by RIF. Next, II by Vi, that is equal to 1 by Ri into 1 plus A beta. 1 plus A beta. By simple cross multiplication, here simple cross multiplication, RIF is equal to Ri divided by 1 plus A beta. Because of shunt mixing, input resistance of a voltage shunt feedback amplifier is decreases. Now output resistance. To get output resistance, input must be equal to 0. So Is must be equal to 0. So we know that Is minus If is equal to Ia. So put Is is equal to 0. Obviously Ia is equal to minus Ia. And to get output resistance, input must be equal to 0 and applying voltage at output side. Here once again I will redraw the output portion of the equivalent circuit. So this is A is equal to, we know that in voltage shunt amplifier A is equal to V naught by Is. So this is equal, sorry, V naught divided by Ia. So V naught is equal to A into Ia. So this is R naught. This is R naught. And here output voltage V naught is applied. V naught is applied. Okay. Now applying the KVL. So V naught is equal to, this is I naught. I naught into R naught plus A into Ia. So I naught into R naught plus A into, instead of this Ia, here minus If is substituted. Here minus If is substituted. Minus If. So I naught into R naught minus A, instead of this If, beta into I naught is substituted. That is equal to V naught. Sorry, beta into V naught is substituted. We know that beta is equal to If by V naught. So obviously If is equal to beta into V naught. So therefore V naught is equal to I naught into R naught minus A into beta into V naught. So V naught plus A beta into V naught is equal to I naught into R naught. Here V naught is taking common, we get 1 plus A beta I naught R naught. So V naught by I naught is equal to R naught divided by 1 plus A. What is V naught by I naught? That is equal to ROF. ROF is equal to R naught divided by 1 plus A beta. So the output resistance of voltage shunt feedback amplifier is decreases because of voltage sampling. Thank you.